Decorator pattern is one of the many design patterns made in the world of object-oriented programming. It allows us to alter our base component or the object by changing its behavior dynamically at runtime, instead of making a concrete subclass to implement this behavior. The main components in play would be the decorator classes, which you can think of them as wrappers over our object. Through the help of these wrappers, we can extend the behavior of our object instead of modifying the original class, hence adhering to the open and closed solid principle. We will start with the simple problem and see what issue does the decorator pattern solve for us. So let us suppose we own a coffee shop, and in that coffee shop we sell three kinds of coffees: espresso, latte, and dark roast. In order to make these classes, we first made our coffee class. Let us call this class our base component. As you can see, this class is abstract and it has two fields: description and cost. Both of these fields are abstract as well, so any class that will extend this coffee class will have to override them. Using this class, we made three more classes, which is espresso, latte, and dark roast. We shall call them concrete components because we're talking about the decorator pattern here. Now let's say your business was making great money and you were making lots and lots of money. But then came Starbucks and they opened their office right in front of you. In order to compete with them, you thought of adding two new flavors to your coffees: chocolate and whipped cream. Your first approach would be to simply extend the concrete components and implement this new flavors. However, this approach is not scalable and it does not comply to the solid principles. Imagine what would happen down the road if you thought about introducing 20 new flavors. You will have 60 classes in total to handle. To implement the decorator pattern, we will create an abstract coffee decorator class. This will simply extend the coffee class. Here, we can add more fields or functions to extend the decorator capabilities, but for now we will simply leave it as it is. Also note that it extends the coffee class, so in object-oriented world it is still a type of coffee. And this is the coffee decorator. Our next step is to create a concrete decorator out of this coffee decorator. So let's create our whipped cream class. As you can notice, here we are simply overriding the abstract fields that we had in our decorator, which we got from our coffee class, which are right over here. And we are setting their getters. As you can see, we are simply modifying what we are getting from the coffee description and adding certain information with it. Same goes for the class field as well. Now also you can see that we are passing a coffee object to our coffee decorator. This is one of the key elements of decorator pattern. Here we are using composition. Composition allows us to add new functionality or behavior to the class instead of inheriting it. As you can see, the cost came out to be 5. The cost of the dark roast is 2, cost of the whipped cream is 1, and cost of the chocolate is 2. 2 plus 1 plus 2 is 5. Also, you can see what drink we made, which is a chocolate added to a whipped cream added to a dark roast. Let us suppose you want to make a chocolate with an espresso. All you have to do is just change this part and run it. There you go. We made it a chocolate which is added to an espresso. Let's say you wanted to add another chocolate. And let's run it. There we have it. So that is what the decorator pattern is. No matter how many flavors we want to add to our coffee, we can simply wrap our concrete component inside our concrete decorator.